Today, we're going to be explaining how to find a derivative using the limit process. If you're like this guy right now, you'll become this real soon. After this video, you will be able to find the derivative using the limit process very well. Let's get right into it. So let's look at x squared plus x minus 7. So we want to find a derivative of this using the limit process. So we're going to need to memorize a very important equation, which is right over here. F prime of x equals the limit as delta x approaches 0 over f of x plus delta x minus f of x over delta x. A good thing to note is that wherever you see an x in your original function is where you're going to be plugging in x plus delta x. So let's see what that looks like more closely. So here we have the limit as delta x approaches 0, x plus delta x squared plus x plus delta x minus 7 minus the original function. And remember, we're going to have to put parentheses because we're going to be distributing that minus sign. So we're going to have x squared plus x minus 7, and all of this over delta x. So now we have to FOIL and condense this all into simple terms. So we're going to have still the limit as delta x approaches 0, x plus delta x times x plus delta x. We're going to FOIL this. This would be x squared plus 2x delta x plus delta x squared. Then after that, we have plus delta x minus 7 minus x squared minus x plus 7 all over delta x. So as you can see, there's a lot of terms, but do not be frightened by that. Most of you should be able to cancel out. If they don't, then you might have done something wrong. So the 7's cancel, the x squares cancel, x cancels, and that should be it. So then after that, we still have the limit of delta x approaching 0 over 2x delta x plus delta x squared plus delta x over delta x. So now we can take out a delta x from this equation to simplify it furthermore. So we have limit delta x approaches 0, 2x plus delta x plus 1. Make sure that you put plus 1 instead of 0 because taking away a delta x from delta x results in a 1. And some people forget to do that. Also, when you're doing this, make sure that when you want to plug in 0 for delta x, you do it at the appropriate time, like now. Because if you do it before, you'll have a 0 in the denominator, making it undefined. So all we have to do is apply the limit now. So it'll be 2x plus 0 plus 1, which is 2x plus 1. That is your derivative. Okay, so now let's look at a different one. So here we have 2 minus x squared. We still want to find a derivative here using the limit process. We're going to use the exact same formula as mentioned before. So we're going to start by the limit of delta x approaches 0 to minus x plus delta x squared minus the original function 2 minus x squared. All of this over delta x. So now all we have to do is use FOIL method to get the terms and combine them all. So we're going to have limit of delta x approaches 0, 2, and then x plus delta x squared factors out to x squared plus 2x delta x plus delta x squared. So since we have a minus outside the parentheses, we're going to distribute that negative upon all these terms, turning that into minus x squared minus 2x delta x minus delta x squared. Same thing for the original function part. We can distribute that negative, minus 2 plus x squared, all over delta x. So now we look for terms we can cross out. So the x squared and the 2 can be taken out. Now we're left with the limit of delta x approaches 0 minus 2x delta x minus delta x squared over delta x. Again, like the previous one, we can take out a delta x from all these terms, which will be limit of delta x approaches 0 minus 2x minus delta x. And now we apply the limit, so for everywhere we have delta x, we apply a 0. Negative 2x minus 0, which is just negative 2x, and that would be the derivative. Let's look at a more difficult one. So here we have x cubed plus 4x. We're going to use the exact same formula as we've been using. So this would be limit of delta x approaches 0 over x plus delta x cubed plus 4 times x plus delta x minus x cubed plus 4x over delta x. So now we're going to have to FOIL out that cubic function. So that would be x squared plus 2x delta x plus delta x squared. So as you can see, what I just wrote down is x plus delta x squared, as if it was FOILing by itself. But now since it's cubed, we have to also FOIL all this by x plus delta x again. So this would look like x cubed plus 2x squared delta x plus x delta x squared plus x squared delta x plus 2x delta x squared plus delta x cubed. After we do all that, we combine like terms. So we'll have x cubed, and after that we have 3x squared delta x, and also 3x delta x squared. And finally, we will have plus delta x cubed. So since we have that, now that'll be the limit. Delta x approaches 0 plus 4x plus 4 delta x, distribute that 4, and now we distribute the negative, minus x cubed minus 4x all over delta x. So now we should be able to cross out terms such as the negative 4x, the x cubed, and that's all we can cross out currently. So then we will have the limit of delta x approaches 0, 3x squared delta x plus 3x delta x squared plus delta x cubed plus 4 delta x over delta x. So now, from all of this, we can take out a delta x. So that is exactly what we're going to do. The limit delta x approaches 0, 3x squared plus 3x delta x plus delta x squared plus 4. So now we can plug in 0 for delta x, and that'll look like 3x squared plus 3x times 0 plus 0 squared plus 4. So this will become 0 and cancel out. So then we're left with 3x squared plus 4. And that would be our derivative for that equation. I hope this video helped you guys. Don't forget to like and subscribe, and I'll see you guys in the next one. Goodbye.
I suppose that calculus, I don't need no calculator, I don't need no computer, no to curve the professor.